My name is Lara and I'm a principal scientist on the research team here at SAGE, and I specialize in systems biology. I have a pretty eclectic scientific background, so I have degrees in physics and in pharmaceutical chemistry, but have spent the last 10 years working really in cardiovascular disease genomics. And I think that this eclectic background is part of what made me so interested in working at SAGE. So the ultimate goal of the kind of work I'm doing is both to potentially identify biomarkers that can help in narrowing the range of treatments that are options for a given individual. The idea of personalized medicine, to try to have a better idea of which medicine is going to benefit which individual before providing it to that person. And the added goal, and what I think is really going to be the really exciting thing to come out of pharmacogenomics, is the use of this information to identify new targets for new drugs. So the way we're going about that is primarily by looking at genetic associations with treatment response. So really genotype by clinical phenotype analyses. But what I've found, particularly with some of the resources and expertise at SAGE, is that integrating layers of molecular information into that kind of analysis is really beneficial in order to try and to narrow the playing field and understand what targets we're really looking after. I think that integrative genomics, this field of bringing together many layers of molecular data in order to get a bigger picture of disease and of treatment responses, is a really new field, and that really exciting things are going to happen in the next 5 years. I think there's going to be all sorts of interesting discoveries related to the subsetting of individuals in diseases and treatments, so we'll have a much better idea of how really we should be treating people who are sick. So some of the exciting things about working at SAGE are really, it's really this concept of integration. There's integration across data sources and data types, and there's integration across the teams. So we have people with all sorts of different expertise, and rather than having one person who's really the scientific lead on a project and works on it on their own with a team of, their graduate students or postdocs, we really work in a team-based setting, bring together many experts to work to solve a problem, and we find that that is just a much more effective and faster way to answer questions and solve these problems in human health.